Our next session is Jira performance testing in pictures. This is a really interesting presentation, and we are joined by Ed Bukowski from from JP Morgan Chase. He is their lead architect, and he's got 20 years of experience in a number of different domains, including defense, e-commerce, finance. He is also joined by Michael March. And Michael is from ISIS Technologies. He's a senior consultant there, and he's been working with Atlassian Applications and helping bring our tools to organizations ranging in size from two-person shops to Fortune 500 companies. Yep. So without further ado, I'll let them take it away.
Hello. Again, this presentation is called Jira Performance Testing in Pictures. And it's specifically measuring big Jira, and we'll explain in a second, at JP Morgan Chase. Holy smokes. Oh, well, that was a weird transition there. Anyways, again, thank you for the introduction. I am Mike March, of course, and one little small goal I have is get as much Twitter love as possible, if I can say that now. So, I'm at Comics, and then there's Ed, of course. Say hi, Ed.
Hi, Ed Bukowski, lead architect at JP Morgan Chase. I work in the Developer Collaboration Tools group. So we do integrations with and new development tools for all of the developers in the Chase community, and that covers the Jira tools like, or the Atlassian tools like Jira and Confluence and Stash and integrations between those. So,
thanks, Ed. Okay, so what are we going to cover during this whole presentation here? So at Chase, well, at any organization, but you'll find out, especially at Chase, performance testing is critical. And having the right tools to measure that and to do that whole process is very important. Those tools have to be able to generate the proper amount of load that simulates real-world usage. You have to be able to measure that load. You have to be able to evaluate what happened and communicate. Organizations like Chase have huge IT departments and beyond, and you have to be able to kind of show what's going to happen during an upgrade process or whatnot. And this presentation is kind of like it's a walk through a history and the present. I'll be doing the history. Ed will be doing the hopeful future. So I'm the ghost of Christmas past, you might say, of every upgrade done at Chase on Jira and what was done to test that. This is freaking me out here. And we'll go through the current tool set, which again will be Ed. So let's talk about Jira at JP Morgan Chase. Hopefully you'll find this very impressive and daunting. So first of all, there are 19 production instances of Jira just in Ed's group. There's more all around the company, but these are the main ones. There are 76 server instances. So there is dev, UAT, production, and disaster recovery. I think Ed could give a whole talk on just that DR tier. It's amazing what they've done there. There are across those 19 instances, as of this slide, which is getting kind of old now, we've been iterating of this for over a month, over 7,000 projects across all those. There are 55,000 plus active users accessing these all the time worldwide. And again, as of the slide, it's old now. There's probably right now as we see 2.5 million issues across all those nodes. What's not on this slide is the massive amount of permission schemes, custom fields, workflows. That's even more daunting than what you see on the slide, but it's all huge. So here, this kind of goes through all of the upgrades that we've done over the past 4 years here. So you can see, let's kind of go through this here. 2011, 4.2 was an upgrade. Next one was 4.4.5, which I'm sure you guys all gone through that process. Where with 4.2, we HP LoadRunner was used. In 2012, JMeter was used. In 2013, 5.1.8 was done, NGrinder was used, and we'll go through all those. And of course, we'll talk about the future with that trio of tools there. So let's go through the first time that we did this very serious process of doing performance evaluations here. So HP LoadRunner. It was used from going to 4.2.2 and a little bit on the 4.4.5 upgrade. And this is the standard tool used by JP Morgan Chase. If you're some team that has a web application and you don't have in-house QA, you just default to this group and they run this tool for you. And it's a centralized team. So you just go, I need this kind of done, and they kind of figure it out for you. And if you don't have those resources on your team, it's great. But it's kind of an ivory tower. It's an ivory tower type model where because you're not doing the work, you don't know exactly what's going on, and they do collaborate well, but just the fact that it's a different team makes it not so tight. So when we got our test results back from them, the first thing you'll find here is that at least everything was published on the web, but unfortunately SharePoint. We love all the Atlassian tools, so that was kind of, it's on the web, but not really what we wanted. We like to use Confluence. And the graphs that output here, this is a pretty nice graph. So you can see here, the green was the previous version of Jira. I'm sorry, no, the new version. Blue is the old version, and it shows you as load was ramped up, the new version of Jira, it scaled pretty good. However, you can see this graph is static. Say we find something interesting on here and we want to zoom in, not really possible. It's a statically published graph, and for us to not in this one, but in like other examples, you're not allowed to really, or there's no way to kind of deep dive into it without rerunning the test or going through a whole hoopla. Here we have a different graph where we would love to have deep dived into some things, but you can tell we don't know what the heck's going on. We can't zoom in. This is where on the previous graph it looked pretty good. This static graph here really was hard to figure out what was going on at any point. Say we want to see what's going on at any point in that curve, not able to do it. Can't drill down. So let's kind of go over what we got. We have a little scorecard that me and Ed created about what each tool did and how they all stacked up to each other. And you'll see here that, first of all, LoadRunner did allow us to perform or to compare performance between runs and between different iterations of Jira. The publishing was easy. We didn't do anything. The team did the test, and magically they appeared on SharePoint. We didn't do anything magic. There was some, we don't have it in these slides, but there was some correlated client-server data where we could see what was going on with the client stats and also how the load was CPU, some simple server-side stats. So we could see when this happened on the client-side stats, what was happening on the server. And then, again, easy report generation. We didn't have to do anything. It was kind of done for us. Not exactly what we wanted a lot of times, but it was easy. So let's go through. Let's go closer in time. 2012 4.4.5 upgrade. So what was chosen was Apache JMeter, and it was used for the 4.2.2 4.4.5 upgrade cycle, kind of both, and not really the slides. There was an upgrade to Confluence 3.3. It was open source, so HP LoadRunner, now open source. It's very expensive. We couldn't just download it and start to use it, but Apache JMeter, we just can go frictionless, up and going. It was very easy to get started. And to that point, Atlassian offered a lot of stock scripts to get going. So we didn't have to do a ton of work to just start out of the box, get it to work. You know, we did do some extensive mods to it, but right out of the gate, we can start be productive right out of the bat. So this kind of slide here shows the kind of 4 steps. We would run the tests, and the UI is kind of crazy. It's like trying to program the registry in Windows. Kind of crazy. So you would run the test there, and then because we had this massive farm, we had to run multiple instances, and we had to aggregate the results from each client on our own. Then we had to assemble. We had to write Java programs and other things to assemble all those logs into one master log, and then we're sitting in Excel making graphs. Pretty graphs. Told story I want to tell. A lot of work. Easy to get the test going, hard to assemble. You see, and then we slapped them in Confluence. Everyone loved that. We could all collaborate on what happened during the test and talk about it and what have you. Nice Excel charts. Again, Confluence. I'm not good with these callouts. So scorecard. So JMeter, a lot of these things hard to compare runs. Publishing wasn't easy. However, good things, easy to execute tests. That's great. It is open source. Atlassian has tons of information on it. And we could control the test data. So if we saw something wrong, we could rerun it. And that was very valuable, especially when we're iterating over constant upgrades, tweaks, and whatnot like that. So 2013, 5.18, NGrinder. I think this is Ed's baby here. NGrinder, used for the cycle between 445 and 518. Again, it's open source, easy to get started, tons of stuff from Atlassian on it, great articles. Again, you can be instantly productive. And it's web-based. So you saw where JMeter has that wacky fat client. It's all web-based. So you can centralize it. It's great. Here's the interface for it here. And you can see here, all your scripts are on Python Groovy. They're all expressed in clear programming language. You can easily, version. In fact, and well, you can run the scripts right from here to test. And as built-in Subversion, which is good and bad, but is better than JMeter that had nothing. So it's all a self-contained test suite. Again, instantly be productive. Here's the NGrinder interface here. It deals in the concept of like agents. It can actually capture and correlate host data. So as you run an NGrinder test, you can have a little client running on your server to collect CPU stats, garbage collection, and whatnot. You can kind of start and set all your duration count and how you ramp up your test to increase load over time. And again, here's your little chart showing the agents over time and whatnot. So here you can see it produces some pretty nice graphs. And you see here, if you want to correlate server side and client side, you kind of have to do some wacky two-browser thing going on there. It does do it, but it's kind of hard to figure out what's going on. It's all after the fact. It's all you run your tests, and then you can kind of see what's going on. So if you have a long test, it might be like an hour. You're kind of like waiting for it to like be done. Again, their client. I should get these. And right there is where the server-side stuff pops up. This other browser window right there. So scorecard. Let's kind of go through this. Easy publishing is good. Not easy to compare between runs. It's easy to execute and run tests and modify them. It was a dream. In fact, we still love it to this day. Open source, again, is great. No friction in it going. No one to ask. Don't need to ask the man. Just do it. Tests available from Atlassian. Again, great resources. We controlled the testing data, and having it web-based made it easy for one of us to set up tests and everyone else to run them and to rerun them. So that really made it great. And there's one other thing on here is it's easy to version your tests also. With NGrinder, not NGrinder, excuse me, JMeter, it's very hard to version and to store and save those tests. So next, I'm going to, for Ed, for the hopeful future.
Okay.
Take it away, Ed.
So now I'm going to talk about what we're doing now for Jira 626 testing. We liked a lot about NGrinder, but what we didn't like was, or what was missing was the ability to correlate data, client server, see that real time, and then combine that and really understand what was going on in a performance test. So we looked out at the tools that were out there, and we came across kind of a trio of tools that really got that information together in a way that we liked and would present the story in a way we wanted it to be presented. So we found Gatling. It plays a role of NGrinder as being the client-side test driver. InfluxDB is a time series database, and then Grafana is a graphing tool that we can use to chart either real time or after the tests have occurred. Basically, you know, again, kind of recapping the previous comments, the single test approach just wasn't working for us, and having, especially, NGrinder got close, but having to put that data, you know, on that screen with the separate browsers, that just was not doing it for us, either for presentation or for data exploration. So this is what the architecture looks like with the different tools. Gatling's a stress tool. It generates the load test. It'll do it across different types of agents. And there's a nice plugin available that will take that data that Gatling's generating and put it into InfluxDB. Same thing we have going on with the Jira instance under test. There's a nice plugin out there that will capture server-side metrics like CPU, disk I/O, network I/O, and also critically garbage collection information, and put that in the InfluxDB in the same format. And then we can use Grafana to pull that out and do some real-time charting about what's going on. I have a couple of screenshots on these tools working, and I've got some videos to show of a live test. The first screenshot is actually IntelliJ. So a big advantage from the previous tools is we get to use IDE of our choice, in this case IntelliJ, but you know, some of the other developers prefer Eclipse. To develop our tests, we're not limited to a web environment, but we can still get the full power of an IDE for testing. And the tests are written in a DSL, a domain-specific language. So it was a little bit of work to go from Groovy, but not too bad. And being able to use our own version control system, our version control system of choice was huge too. Again, NGrinder was nice because it had version control, but it limited us to Subversion. With Gatling, we could use whatever we wanted, and it integrated cleanly with the rest of the tools. We used Jenkins. Gatling will run standalone, but we use Jenkins to run to coordinate the tests. There's a plugin available for Jenkins, and you run it like you would any other build. You hit the Build Now button, and it runs like any other Jenkins build would. It has the history, and it also shows you some nice trending metrics around how your tests are progressing over time. Are we seeing the improvements we expect as we make adjustments to the servers? So this is a video of a performance test we did. We start off in Jenkins here, and we have all-person simulation, which is 4 separate scenarios that we're going to be running on this instance of Jira. And again, we start it like we would any other Jenkins build job. We hit the Build Now button, and the test starts. It shows up in the build history area, and we're going to drill down and look at the real-time output we're getting from the console. And this is the same output you would get, by the way, if you're running this standalone inside of Gatling. There's each of the scenarios that we're running. You know, we're running an admin test, an issue browser test, project manager scenario, and an issue creator scenario. And we get some of the, like a subset of the data that Gatling's generated, and it's all client side. So we'll see things like the number of waiting users, and we'll see things if there's any errors being generated. And this, you know, the little swirly at the bottom means this is real time. So this will update as the test runs. So this is fine. This is great for kind of command and control, but this isn't allowing us to correlate any of the data that we're getting from the server. So that's where Grafana comes in. So this is what the Grafana dashboard looks like, and you can see the little swirlies occasionally appear to show that it's updating in real time. On this top row here, we have users, the number of users we're throwing at the system, the total number of requests that are being sent to Jira right now. And then we're also getting some server-side information. We're getting CPU, what's going on the server's load, and then also we're getting memory information. So what Grafana does, because it's just a graphing tool into InfluxDB, we can make charts on whatever data is being collected. So in this case, what we want to do is look at the response time by scenario. So we have separate graphs now for the issue browser response time, issue creator response time, the project manager, and the admin tests. And these are real time. As we test, we can see if maybe one scenario is driving, is having issues, or it might be driving some interesting activity on the server. We also can drill down on server-specific information. We've replicated the CPU chart, but we also now have our disk I/O chart, our network I/O chart, and our memory utilization chart. And then, of course, Jira is a Java application, so what we really, really want to see is how garbage collection is doing. So we're going to create 6 charts to track garbage collection. We've got OGen utilization, Eden utilization, PermGen, total garbage collection counts, and our young generation garbage collection count. So all of this now is on one awesome dashboard. It's easy to read. It's easy to see what's going on, and we're doing this real time. This totally blew away everything that we were doing before with NGrinder and the other tools. The other thing we can do is we see an anomaly like CPU, that spike in CPU usage. We can zoom in, and all the charts zoomed in at the same time. So we could see what was going on with other data that we were collecting at the time that anomaly occurred. We also can go into a specific chart and make it full screen if we wanted to, while the test is running. And if we wanted to drill down in a specific area, like, for example, network, we can make that chart full screen and see detail. And these charts are fully zoomable, so we can go in and look at any kind of anomalies or export that data as necessary. There's also an option to look at predefined time periods if we want to go back 5 minutes, 10 minutes, 15 minutes, an hour. We can do that very easily with some presets. And this comes in handy too because we run several tests over today. And if we wanted to kind of compare test runs and go back to see how maybe we changed some garbage collection parameters and we want to see the results of that versus a previous test, we can control all that just by zooming in and out of particular charts, like the users chart in the upper left corner, and all the other graphs will immediately update. You can see on, from the all request chart there, we had, those 6 peaks. We've ran 6 tests during this time period. So this is Grafana. I'm going to show Gatling, and then we're going to kind of zoom in a little bit more on that CPU anomaly so you can see how we use the tools to drill down on that. So back in Jenkins, again, Jenkins is kind of the command and control, and there's a nice integration with Gatling through Jenkins. And we can look at performance trends over time to see how changes we're making are impacting the load tests. And we also can drill into the Gatling charts, which gives us a tremendous amount of information on client-side metrics. This is what the Gatling reports look like. They show a lot of detail on each scenario broken down into specific tasks and telling us things like execution counts, errors, any kind of lag, anything that might be interesting at a sub-scenario level. And all those charts are completely drillable. And then we're also getting other data like active sessions during the simulation. And you can see each of the 4 scenarios are corresponding to a different line there. And these charts are interactive, so we can hover over certain areas, hover over points, and get detail about what was going on at that point in time. So this really helped first it helped communicate to management what was going on with the load testing. It helped communicate to our infrastructure partners, like what was specific types of tests or specific bottlenecks that we encountered. And these are some of the other charts that we get out of the box with Gatling. Response times, number of requests per second, the number of transactions per second. And the other thing we can do with Gatling is drill down into a specific subtask. Here we're going to drill down into the browser test part of that overall scenario test, and we see much of the same data, or we see the same classification of data, but specific for this task. And we can zoom into a specific time frame and look at what was going on for this one piece of that one test. And again, it's broken down into these other testing areas like latency, response time against the global number of responses, against a global request. So this is Gatling. We really liked the client-side data that came out of Gatling. We liked the charts, and we liked the way it was interactive. Okay, so one more video I'm going to show. This one is how we used Grafana, how you create charts in Grafana and how you drill down into your data. So we're back in Grafana. And what we're going to do is look a little bit more at that CPU spike that we saw. In particular, how it was associated to this peak in the admin response time that seemed to come out of nowhere. So we're going to create a new dashboard, and we're going to create 3 panels to look at the different types of data, client and server, that we were collecting. So first we're going to create a panel for the admin response time. Then we're going to create a panel for CPU usage on the server at the time that that test was being run. This is all after the fact too, by the way. This was like the next day after the test, and we're kind of looking through it, and we saw this anomaly, and we want to look at it some detail. And we're going to look at a garbage collection data through a separate panel. After you create the panels inside of Grafana, you attach the query to them. So we're going to write a query here. From series, you see as soon as you click on it, it starts to fill in a lot of the data. So there's like a lot of type ahead and things like that, which makes building queries inside of Grafana really fast. There are aggregation functions. In this case, we picked max, but you can do averages and different types of things. And then we're going to label this. This was our Jira 7 instance, not actually Jira 7, but our Jira 7 instance that was under test, so we label that. Now we're going to add a query for the CPU. Again, you click in there and it starts to fill things in. So it makes this fast and easy to get some custom charts going versus the way we're assembling this in Excel with JMeter was just a nightmare. So this is 10 times better. We'll label this as our CPU chart, put that up there. In this case, we're going to change the color a little bit just to make it easier to view. And now we're going to add queries to our GC panel. In this case, too, we're going to look at the Eden utilization and make sure we capture that. But we can, in the previous dashboards, we were showing like one series of data per chart. But in this case, we're going to combine a couple and show the garbage collection on the same chart, the garbage collection counts. So again, it's as you pick one series and you select values, Grafana kind of real-time queries the database and makes the query building pretty straightforward. We're going to add a label here for Eden utilization. And now we're going to capture the series data for the garbage collection count. And what we're really looking for here is to see how that young GC count is stacking up for when, how the young GC memory utilization is changing as your garbage collection counts are starting to go up. So we changed the colors there and do some graph adjustments. But what we noticed when we drilled down, this wasn't really a CPU issue. This really was a garbage collection issue. That at the time we saw that spike, there was a lot of garbage collection activity going on in the server, which was stalling our requests. So armed with this, we were able to go into the server and adjust garbage collection settings to better account for these types of situations. Okay. So one last screenshot as we close out the Grafana discussion. This dashboard view was just awesome for us from a testing tools perspective. We could correlate client and server data on the same chart. We could drill down and explore in real time what was going on, and we could get answers to other teams and to our management about how Jira was doing. So from a scorecard perspective, Gatling, InfluxDB, and Grafana really allowed us to check most of these boxes. There are two that aren't checked. Unfortunately, tests aren't available out of the box for Gatling from Atlassian. What we're able to do is take the NGrinder tests, modify them, with some assembly required. It took a little bit of work, but we were able to modify them and make them generate like the same flavor of tests inside of Gatling. And the jury's still out on easy report generation. Those dashboards are nice, but they didn't automatically integrate with a publishing tool like Confluence. We're probably going to have to do some screenshots and manual stuff to get them into there. I don't know what all those flashes are. Okay, so you can't really talk about performance testing and not talk about performance factors. And a lot of this material actually is straight from Atlassian, but there's some common things that impact Jira performance. One of them is issue count, custom field counts, permissions, and concurrent users. These are the big four. And there's a chart published out by Atlassian that really nicely summarizes what's going on with these factors. In this chart, what they did in the bold, they changed each one of those factors while keeping the others constant. And then the throughput results there on the far right, the top is the best performance and the lowest is the performance that started to suffer when those variables were changed. And again, the bold is the changing of the variables. And what was found, and we've seen this countlessly in our own test, is that issue count is the biggest impact on performance. The more issues you have, the slower your Jira is going to run. Chase, we use a federated model. So basically, issue count gets to a certain level, and we call it splitting an instance, and that's how we end up with 17 instances over time. We proactively will move projects and their associated issues to a different instance. And that's not easy for us because we also have to bring over schemes and everything else that might be linked to that project. So it's a bit of work, but we have to do it to maintain the performance curves that we want. Okay, so key takeaways. Pick the right tools for the job. You can see our tools changed over time as kind of our needs changed and our maturity as a team changed. I'm still kind of partial to NGrinder myself. I thought out of the box it did most of what we needed, but it just couldn't do all of what we needed, so we moved on to these more advanced tools. But if I was time constrained or in a smaller organization, I definitely would look at NGrinder. Related to that, know your constraints. How much resources do you have? How much do you need to test? How much time do you have to test? Know your goals. Are you trying to target a specific amount of users? That's going to have a different sort of testing profile than if you're trying to tweak your server for certain garbage collection parameters. And then also something we learned was to reach out, talk to Atlassian, utilize all the resources that they have, reach out to Atlassian partners like Mike and his team, because they have experience in that area too and can really help you out and point you in the right direction. And I've replicated the scorecard there just so you can see what was going on. So that's our talk. Thank you for coming. There's a kind of a missing member of the team. There was an individual, George Simpson, who did a ton of work, but at the last minute could not attend today. So we wanted to give him credit here on the last slide. So thank you again.
Thank you both so much for that. We actually have time for a few questions, so we were monitoring questions as they were coming in. So how many man hours or months of effort would you say went into this?
Okay, so this, I think, is a good segue from the NGrinder discussion. NGrinder, we could get going. We had a smaller team, and we could get that going a lot faster. We had more resources at our disposal for Grafana, InfluxDB, and Gatling, and that took a lot more effort, honestly. Some of those plugins didn't exist to get those to work. And yeah, to answer the question, how many man hours? We spent weeks getting those tools working right. It was worth the effort because of the data we got and the way we could, most critically, the way we could share that with our other infrastructure support teams.
So I'd like to add to that, a lot of those tools are new, especially InfluxDB and Grafana and that hookup. So it took a while. I mean, there's not a lot of Googling resources to figure out how to do it. We got it going, we got it automated. But it is a lot of work, and also when you create your tests in Grafana, you can get really detailed and crazy. I think to do base tests that are pretty comprehensive, not that hard, but George is not here. He's a perfectionist, and he really created these tests that simulated a full browser in that language. So you can make it as much work as you want, but even just getting the base stuff going was pretty hard. We're going to put out some documentation to how to do it. Hopefully we'll help you guys.
Thank you. So you mentioned a Jira plugin earlier that you used for capturing GC data. Do you remember?
I can't recall, but it's on the slide. Feedback.
It's called
mod, sysmod.
Sysinfo. So it's not actually for Jira. It sits on the Jira server, and it attaches itself like a barnacle to the JVM and the basic OS. So it collects all the disk I/O stats, memory, and JVM specific stuff. So it's not really for Jira, but it collects all the stats that we needed from Jira to make it work.
Well, and these slides will be available, so you'll be able to reference that for the few people who asked that question. Let's see. So while the load testing is practical, have you attempted to implement this as a 24/7 monitoring solution on a live production Jira?
Yes, we're looking at that because this is something that we found with InfluxDB, which was kind of a bonus we weren't expecting. We attached the Barnacle, as Mike said, and the Barnacle kept spitting out data. And now we've got a profile that we can put into our production instances. And after the fact, if there's an issue, we can go back into our InfluxDB and look at what was going on and see, much like you just saw with the custom charts, we can go drill into that data and see what happened and what was going on with CPU, memory. Maybe somebody was upgrading a router or doing some other kind of maintenance work at that time. Those charts would help us look at what was going on and figure out why we got that spike or that degradation in performance.
To further on that, InfluxDB, if you look in that project, it's a time series database. It's actually made for that purpose, actually. We're using it for a purpose that's not really what it's intended for. It's made to do long-term. Is very efficient on disk. It stores everything compressed on disk, and it's optimized for this kind of data. So actually doing it for that purpose is more proper than what we did, although it worked great, obviously, for our purposes, too.
Great. Thank you. So you showed us quite a few different testing products. Can you talk to us at all about the pricing on these?
They were all open source except for LoadRunner. So
just your soul is a price, that's all.
Hopefully there's no HP people.
Small price to pay. Do you use the same tools, Gatling, for example, to monitor production in real time for post-review?
Gatling would not do that. InfluxDB and the Barnacle was our kind of first foray into monitoring production after the load testing was over. And again, that was a nice bonus.
Yeah.
Great. Let's see if we've got one or two more. Okay, great. Are any of these products more efficient in terms of utilizing resources to create load?
I'll go. Want me to go?
Yeah.
So we can't talk about HP Load Center because we didn't run it, but Gatling is amazing, super efficient. It can create on one server more like it doesn't use threading; it's MBIO, and so it is way more efficient on one. Where with JMeter, Ed and his team would have to do wide and have all these servers. Gatling, you can do that also, but you can do a lot of load on one server. It's very, very efficient. So
related to that, kind of a difference between Gatling and NGrinder. NGrinder was used language like processes, threads, and agents. So we had to, well, we're targeting this many users, we kind of had to do a translation between processes, threads, and agents to users. Gatling was much better in that respect. It started off about simulation scenarios and user counts. So we didn't have to do these translations, and it was much more natural.
Perfect. I think we've got one more. Let's see. All right, so you're splitting Jira servers at around 400,000 issues. Are you using hardware or VM hosting?
We are using VM hosting. We talk a lot about using hardware because we think it would improve performance and give us more control of our environments. But right now we are using VMs.
And a quick kind of comment on that also is, the interesting, all 17 instances point to the same instance of Oracle. So it's not like the actual database itself is shared. It's just the CPU and the thread. I mean, it's all application server type stuff, and the Oracle is all the same.